Okay. All right. Hey, everybody. Glenn here. I'm going to do a post today, a little bit different than I normally do. This one's going to be on Kubevirt. I've been wanting to do a demo for it. Just put it out there, see if anybody like knows anything extra or has any input or anything like that. All right. So first thing we're going to do, we've already built our Kubernetes cluster. So this is going to be, I don't know if anybody knows anything about Kubevirt. What Kubevirt does is it allows you to run VMs inside of a Kubernetes environment. So QEMU instances, if anybody knows anything about Linux, it inherently has the ability to run VMs inside of it in general. So really, we're just using the built-in resources to expose the API for us to stand up VMs and manage them, just like we would if we were in vSphere or VMware, sort of. It also allows us to define actual definitions of our VM definitions, and a bunch of other stuff. So what we're going to do today is we're going to actually build a domain controller, so a Windows server that actually has a physical NIC running with it without doing the kernel pass-through, because we're going to use multiple VMs using this same NIC and not have it run on our host interface. Because we don't want to run on our host interface. Our host is doing CSI traffic, all of our CNI traffic, any of our services for our Kubernetes instances, anything between our hosts, any of the things, if anyone knows about it, IP table stuff or anything like that the Linux host is actually handling for our Kubernetes instance. All right, so I kind of put some of the stuff, I built this before, and a lot of the stuff we're going to need is already inherently at Kubevirt. So actually, where did it go? Oh, crap. Apparently, boop. We're going to go right here. So if we just go to, if we just type in Kubevirt, it'll take us to kubevirt.io. I like going to their GitHub instance. So you're going to need to pull all your requirements. So Kubevirt, we're just going to go to our releases. They are GA now with their 1.0. So you want to get your custom resource YAML, your operator YAML, and you're going to find your virtctl for whatever architecture you are using. I've already pulled all these down, the AMD 64, and and the operator and the CR. I've actually already deployed all this, but I went through earlier and deleted the VMs. I'm not sure how long this app actually lets me record, so I don't want to make it too long. Some other dependencies we're going to need. We're going to need Multis. So go to Multis and grab its release. I think I've got the current one. You can pull their stuff. This is for the CNI. You can also, or for their Etsy CNI netd stuff. You can deploy that, or you can just pull their, what is it under? Deployments Multis daemon set. So you can just go under deployments. And I deploy, I think I've got the thick daemon set deployed. I believe there's a couple different ways to do this, but you only want to do it one way. Whereabouts? I think I've actually got it, got Multis deployed. Yeah, I got a thick daemon set deployed. I just deployed it like that with my my portions. You're also going to need Whereabouts. What Whereabouts does is it is a CNI IPAM, but it's a cluster-wide definition. If anybody knows anything about Kubernetes, your CNI only manages your local host IPAM. So it monitors that. What this allows you to do is to set a network attachment. When you set your network attachment definition, to set a DHCP pool. So as soon as the VM goes down on a node, that IP will then be released back to the entire cluster and won't be just monitored on that single node. You can go here. If you just look inside of here, it's under their stuff. their daemon set, their IP pools, overlapping range, and all that stuff. Once again, it's inside of all of their instances. CRDs, see, bam, just go in there, grab what you need, and pull them down. See, bam, it's all your stuff. So we've got Kubevirt, we've got Multis, we've got Whereabouts. There's also an additional one for this, which is is this inside of Kubevirt? It is their cluster network add-ons operator. What it is going to allow us to do, if you look right here, you can install Multis with this. You can do dynamic networking, but what we want that Linux bridge option right there. So go ahead, grab your stuff. The directions are on this web page. Go to it. It's pretty much just the let's see. That's the config CR that they have. I'm not sure which one they actually threw it in. No, that's their metrics. You can build up their own stuff if you want. I can't remember where it was at. I've already pulled it once. You can probably just go here to your version. Bam, it tells you right there. GitHub Kubevirt cluster network add-ons operator releases. Just go ahead and pull that. You can just do a wget and pull those down, or just go right here, download these and pull them down. Make sure you get your namespace, your network add-ons config example, and your config CRD and your custom resource definition file. Okay, like I said, I already pulled this stuff earlier, and I've already deployed it. So we're going to go to our server node. This is our first one. Let me see if I can make that a little bit bigger. And can I move myself out of the way? I cannot. I'm going to turn myself off. All right. So what we're going to do is we're inside of our server node. Go to our network attachment definitions. Look at that. All right. So the first thing we want to do is we're going to want to, of course, get our virtctl. If y'all remember, if you go right here, you just go to Kubevirt's releases, grab your virtctl. Just change the name. I changed it to virtctl and stuck it inside of my user bin directory. See right there, threw it inside of there, made it executable. And then we're going to take and we go through all of our files for all of our Kubevirt stuff. So we deploy our Kubevirt operator, deploy our custom resource YAML. Then we're going to wait and actually wait for it all to come up. Another instance you're going to need in order for Kubevirt to operate is you're going to need your CDI stuff. I did not bring that up. That is also, I mean, if you just do like this, it's amazing. There is a actual Google actually will find it all for you. There's all your stuff to pull the CDI operators. You can just go here, boop. I'm going to click on this latest release, and bam, there's all the stuff I need. So, all right. So now we get our CDI operator going. You will need to move your ISO over. So once we have virtctl installed, we will do an image upload. We're going to create a PVC, persistent volume claim. I'm going to call it ISO Windows. It's whatever you want to name it. It's just my ISO. And I'm going to dictate my image path. So this is on my local host where that image exists. It's in my home. Pervadmin. Of course, it's the name. I could have changed it. I was having issues, so just kept the Windows the same for a bit. Downloaded the ISO ROM before. I'm going to do access mode. I want this to be read-write mini. It's going to be 10 gigs because I think the image is like 8 gigs. I'm going to use my local storage class of rookceph fs, so my file system share. And then I'm going to find my my upload proxy. Say I am. Bam. Let's move this over here. So a way to do that, let's close you out. Boop. All right. Boop. Is we're going to go to once Kubevirt or our CDI is deployed, We'll filter it right there. Notice I have my upload proxy. I'm using Rancher. You can, it's just what I'm using for my UI management. But if you look right there, 1043, 146, 117, 443. If you don't have Rancher or you just want to use the UI, okay, get svc dash n CDI, I believe is what the namespace is. And there's my upload proxy. See 1043, 146, 117, and port 443. That's what you're going to do right there. Make sure it's insecure. It does a lot of checks. It causes some issues. This wait second, I had to up it. I was having some latency network issues, so upped it a little bit so it didn't cancel out. It actually let it run before it started. Once I get that, it's going to create, I'm going to use Rancher just because it is a nice PVC for me, or it is a nice UI for me to show everyone what is going on. So I'm going to go right here. I'm going to go to persistent volume claims. Once my machine comes up, I will then have my ISO windows. So ISO windows, read write mini, CFFS, bam. I've made a couple different ones, ISO Win Desktop, ISO Rocky. I can reuse this at all times. They're always a bootable ISO at all times. So when I make my definition for my VM, I just set that as my boot. All right. So now we should have our ISO uploaded. If you run into any issues, CDI has some troubleshooting steps. This most of the time works. I have not had any issues with that step or with that in a while. Next, we're going to have to create all of our dependencies. So we need to install whereabouts and our network add-ons. So network add-ons, you should do your namespace YAML, go in and do your add-ons config CRD, and then do your operator YAML. So there is, once you get all that going, you need to set inside of your network add-ons CR YAML. Let me go into that real fast. I cannot remember if I did any of the changes on this one. Yeah. So network add-ons CR. I don't think I did. Why is it so high? Notice right here, only thing I did was Linux Bridge and my Mac VTAP. So we don't want to rerun anything of Multis. So once we create that, I'm just using kcreate, just your simple declarative motion. You can do whatever you want. Use your Argo or anything like that. So I put in here in my steps to look for this label on your host. That label is not going to exist yet. That label has to have you have to have your bridge created first. So with that being said, let's go to our bridge and hop on there. So I'm just going to show you on here. Whoops, sorry. So I did all this on a standalone node just to prevent having any issues. I can actually replicate using my bridges and everything. It was not a proven thing until not long ago that it worked. Also, another thing, you want to use bare metal with Kubevirt. That's how it actually operates. So what we're going to do is, let me show you. So I created my bridge. Notice in here, I have my BR0. So if we go inside of it, we're going to look at the actual bridge itself. It has ENO2 added into it. I have nothing inside of there. I have nothing on 802.1x. I have it automatically connect. I actually don't think I have IGMP snooping on there. I set an IP. I just gave a IP in the range to have it a standalone IP for it. Also my gateway, my internal DNS server. We won't go into that. I also disabled IPv6. If you look at my ENO2, which is part of, it has nothing. So no, it's disabled IPv4. I got IPv6 automatic. I'm going to go ahead and disable it. And let's look at activate. I do not have ENO2 even activated, but I do have my bridge activated. So All right. So if we look right here, IPA grep BR0. So that's anything with our BR0. Notice we have our ENO2, which is part of our bridge. Our bridge is set to our master and our bridge IP. Let me go over some of these steps. In order to do that, you can just use NMCLI. I just did like that. It's a little bit quicker and easier, and you can use a CLI to do it. It's faster. So interface name, made my BR0, set my IP, set all that stuff, set it as manual. Then I added my ENO2 as my bridge, and then created the connection name, bridge 0. Brought my connection up, and then let's see, bridge link show. Let's see if that'll actually show anything right now. Yep. So right there, bridge link show master NO2. All right. I set my IP tables to forward to allow BR0 to actually push everything all out. So once that is done, and we have done our network add-ons portion, we will be able to do what I was saying right here. So K describe nodes. Let's do K get nodes first. K describe nodes K8s agent2. Oh, I definitely did not do that right. Dash. All right. Grep BR0. Sure. Bam. I didn't get the labels. I can pull for the labels, but really what I want to see that I have one available to allocate, and it is not being used. That should be that part right there. And if you just do a describe nodes, I can go down. Notice right here, I have request limits, my BR0, 0, and 0. All right. So those are not being used right now. All right. So next, remember I said we need our instance for whereabouts running. So go ahead and install your whereabouts YAML, set your IP pools, and set your overlapping IPs. And because we don't want to waste IPs, we're actually using an overlapping pool that does have some that may get issued with it. It'll also allow you to stand up something that hasn't been fully released yet. So next, after that's done, let's see, we created our bridge. All that is good. We need to create our network attachment definition. So I have an example right here. So what I'm going to do, I have my metadata for my name. I'm going to set, actually it should be, change this to VMnet. I have my Cube system stuff. What I did was I have my annotations there. You want to make sure you have that for your resource name. That's how your network attachment definition knows it's going to look for any host that has that bridge label on it. And then you're going to go into your specs. You can also look at Multis's website to find all this stuff too. My CNI version is 03.1. I'm going to set my name for VMnet. It's going to be of type bridge. I'm going to use the bridge of BR0. I'm going to do my IPAM definitions. I'm going to use of whereabouts to do it. I'm going to set my range. So that's my entire range. That's my entire /24 for my home network. Range start, I'm going to use 126, range in 130. I'm going to set my gateway. All right. And then once I get that, I'm going to create it. So what, let me see. Cannot remember if I threw it inside of here. I did not. I had my network attachment definition somewhere inside of here. I want to recreate them. Network attachment definitions right there. All right. So I want to show what. Let me see. When you are actually building a VM. So with my network attachment definitions, what I do, or with my what I need to do is I need to specify and set it to when I set it right here, where's my default bridge? I did not change them yet. Okay, well, I will not use that because I already have them on. I'm just going to use these. All right. So what we want to do, let's see, Vim, VM net. I remember which one. So for the default namespace, right there. So if you look, we got our VMnet. I went through and did a lot of stuff. I set my domain, set my search zone for all that stuff. Same thing for all of that. I also did hairpin mode for the house. Helps out because I got a lot of randomness going on my network. So what I want to do, let's make sure I didn't create. I don't think I changed this one. I actually did. All right. So let's go here because I want to show you what happens when you don't have it made. We're going to go into when server 2. So what I did in here, when you set these up, this is just my virtual machine definition. So notice I just put my name of what my VM is going to be. It's not running, so don't try to do that. What domain I wanted to set up at, how many cores I wanted to do. This is basically defining your compute section of it. The interfaces I want. So this is my network attachment definition. I wanted to use the VMnet and use bridge it. I want to use my boot order. So I've already done this once. I set boot order 2 because it goes right here. If you look right here, CD-ROM, disk, and then my virt IO. I want to actually have it boot from my hard drive. I've already gone through and imaged this one, so I've already gone through my ISO. It gets down here to machine type. You want to make sure that anything you run is Q35. There's another type that VMs can run, but Q35 is everything of like modern times. So if any of your VMs that you run for Windows or anything like that, they're usually Q35. I'm setting 8 gigs of RAM, networks. This is where I'm actually defining this. So notice how this interface, this name has to exist down here in my definition. So there's my networks, there's that name. And then I define what that's going to be. It's going to use Multis. It's going to be the default. So it's not going to use a ETH0. It's going to be my net 1, or I forgot whatever this one's making it now. And it's going to be called VMnet. It's going to use the network attachment definition of VMnet. And here's all my volumes. I won't go into describing all that, but just notice how I'm using my ISO Windows to boot. And I also have my WinDesk HD. That's my actual Windows hard drive right there. So your C drive type stuff that actually boots your operating system. So I'm going to actually, let me show another one because I have right here. So I commented these out on that one because I wanted to delete it and I just wanted to keep my storage persistent. But you want to create a persistent volume claim for it when you go to make it. I'm going to set my name for it. It's just my hard drive for my 4th VM instance. I'm going to set it rewrite once because that's block. And I'm going to set it 100 gigs. I'm going to use CephFS. Could have used my I think it's Ceph block. Can't remember what the actual version I did, but I did CephFS, so I can do read write mini and use it for multiple hosts to use when I have issues. So now that we've got our ISO loaded, let's see what else we have. We've got our network attachment definition made. What we're going to do is we're going to actually create our VM. So go inside of here. That's all the stuff for the VM. Bam, bam, bam. We've already done a virt CTL. So we're going to k create-f when server 2 YAML. Boop. Our VM is now created. All right. So what we're going to do is I'm going to show you right here in Rancher. You can go over here. Once you kind of deployed Kubevirt, you'll be able to go inside of all this stuff. And whoops, and where's she at? Kubevirt IO. See your virtual machines. So right now I've got, okay, I've got that rock. Oh, that was unavailable. All right, WinDesk 192. That's the one we just did. All right, so you can also do like this, and I can go inside of my CLI, and I can run kubectl git vm-a, see all of it, kubectl git vm-a. So they're all stopped right there. Great thing is, we see that our default namespace, net, I don't have any network attachment definitions made either right now. All right, so I have it set as default. In order for it to run default, my network attachment definition must be made inside of my kube system namespace, because that's the default one that it's going to attach to. So let's go into net attach defs, and then let's k create -f vm-net kube system. Bam. All right. So k git vm-a. All right, now let's go virtctl start Windows 192. Bam. All right. So we can either watch this, but I didn't go over this either, which I should have, because there is another tool you will need to use to get into your Windows machines. That is virtvnc. You can deploy this just into your environment. It's really easy. Deploy your thing. What it allows you to do is go to a node port. So a node port is really just your, let's see, 10.10.0.105 colon. Let's look at which one it is. I don't remember right off the top of my head. It actually is faster to just go to the CLI. Where is virt VNC? Virt VNC. 30250. 30250. Boop. 30250. All right. Let me see if I can go to it. Should let me. Okay. So right now that's pending, coming up. So it's not going to open. Let's see why that one is not coming up. There is a couple of things we can do. We can go right here. Virt launcher pod has not yet scheduled. So we can go right here. Pods. So let's go here. Let's go to default. Clean up some of this stuff. And you're right. Virt launcher has not scheduled at all. So let's see, why is it having issues? Starting CD-ROM ISO reason. Failed to create synchronous, failed to locate network attachment definition default VMnet. Okay, well, I was wrong. And looks like setting default is forcing it to look for our default. That's all right, because I have okay, delete -f. Here, actually, let me go to boop boop. Let's go to k delete -f. That's why I didn't rehearse any of this. So this is all legit, just problems. All right, so k create -f vm-net -default. Oh, vm-net -nad -default. Bam. All right. All right, now that that's made, we can sit here and watch this. It should spin on up. Oop. Actually, we should be able to see this pod spin up. We can speed it up if we want. We can do virtctl, or here, hold on, what's our VM? Our VM is Windows 2, so we can virtctl stop Windows 192, boop. And then we can get that again. Stopped. virtctl start Windows 192, boop. Scheduled to start. All right. It usually doesn't take too long of a time. There we go. Our Virt launcher pod is coming up. Recent events. So we look right here. We can see it successfully assigned it to the Kate's agent. Oh, sorry. Why is it saying terminate? Did I click on the wrong one? I did not wait till it was up and running. That could be why. Dun, dun, dun. All right. Well, let's stop that and let's make sure that this is actually deleting first before we get too far ahead. Okay, not quite sure why that one's freezing up. Okay. Shouldn't be hanging up like that. All right, we can trick it. That's all right. And let's see what we got. Let's go into Windows, VMs. See, what was it? It was server 2. Okay, delete -F and -server 2. All right, there we go. Now let's see if that cleared it up here. All right, so let's try this again. Okay, create -F when -server 2. All right, cool. So that should have created that. Let's look on here just to show you, which we can also, virtual machines. The VMI does not exist because we have not stood it up yet. Now let's just roll and do a virtctl start. Bam. All right, we can go up here to workloads, look at our pods. It is coming up, our Virt Launcher pod, which is going to basically host our services. So it'll successfully launch. It has found the volumes that we had before. So if we look right here, we can see that Virt Launcher, try delegates, mutations. Cannot find network attachment VM namespace cube system. VMnet not found. Okay. That was what I was saying before. You shouldn't have. It shouldn't. It was having issues coming up earlier, but apparently I was right. And when you do set the default, I just don't want to have them duplicated in here. So I'm going to do this to clear it out. Create -F. I'm going to VM-net cube system. I was right. You do need it in the cube system in order for it to exist, or else it will not come up. You'll see right here, cannot find attachment in namespace cube system. So too easy. Rancher gives us our issues. Oh, look, there we go. Add ETH0. That should have been our static IP. Cool. It pulled one from our pool. Add ETH0, set it up inside of there, attached our VirtIO disk, and all of that cool stuff. Another way you can do, you can go inside of here and you can check your actual pod. So this is the pod that's running the VM. And we have our ETH0 right here. We want to make sure it pulled one of the IPs from our network attachment definition. That's how we ensure that it is actually routing traffic. Or sorry, it will be able to actually route traffic in a second. So I've already gone through this and done a lot of the troubleshooting. Usually I can kind of show you right here when we do Virt VNC. It'll let you hop into your VM. And you can run like this if you want. It is very crappy, but I've already gone in and I have configured this VM and everything too. A cool thing with doing it this way is I'm going to go back. What I want to do is I need to recreate all of my Windows VMs again. So I'm going to go to server YAML. Make sure I don't have anything that is going to cause any issues. I should not. Oh. Boot order 2. Okay. I'm going to k create -f win-s server. Okay. All right. And then I'm going to k create -f win-server 3. Just create all of them. Why not? Bam, 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 bam. All right. K get VM-a. It's going to show me all my VMs. All right. Well, let's start them. Virt ctl start Windows 19. Bam. VIRTC ctl start Windows 193. Bam. All right. We can go inside of here. I can look. I can see. Oh, they're pending. The cool thing is with Rancher, I don't have to go into anything. I can like show you right here. As soon as these stupid pods come up, we can see what's hanging up. It's probably an issue with what we were talking about with the actual Virt launcher project. If pod does not exist, ready? No. Failed to locate network attachment. Okay. All right. It shouldn't have any issues. That's fine. Because if we look at our definition, we're going to, if we look at how our definitions are, I want to show that real fast for our network attachments. cd net attached definitions. Oh, sorry. Actually, let's go back to that Windows VMs. And we look at win-r. We'll just look at that one real fast. We have it set up. It is set for default true, and it is still looking for that one. That's okay. It is not going to hurt it to make the default one. It's only going to pull one IP from one of them. So we can just do like this. It's just getting hung up looking for it. Okay. We'll just do that. Trick it. Why not? So what it's going to really do is it'll pull real fast. Maybe something was just hung up on it. You can set little definitions if you want to. Let's see. Did that make a pod come up and hang up? Okay, there we go. Now let's just do this. I never said I was quick at a CLI. All right, bringing up. Okay, 19 and 193 are all coming up. Okay, cool. Something was just hung up. It's all good. We can hop in here. We look. We notice that it pulled a 127 from our stuff, from our Kube system VMnet. For some reason, it's looking for that default network attachment definition first, which, I mean, it's not wrong on it. Even though we define default, it needs to look inside of that Kube system namespace because it needs to use it to come up for the pod traffic and networking. So it has to be in that Kube system namespace, or else we won't be able to use it. So once we're done, I've actually gone in. What I did was I have my range for my VMnet, and I statically assigned my IPs to my hosts. I say I did. Why is that one not up yet? 192, 193, 128. There we go. It's booting up. I just see that I have my speed test already on it. It's okay. We'll go ahead and connect on here. All right. Let's see what one that one is. I don't know which one it actually offered to have me hop in. Let's see what this is. All right. Which one is this? I don't know which one that one is compared to any of the others. 134 is the one I wanted to. Okay. All right. We can do like this. So one thing I'll do is once I configure what you need inside of it, hop into CLI or the command prompt. Make sure I can ping. Look at that. I'm pinging Google. See if I can ping google.com because those are two different things. It means my DNS is working. So one thing I discovered when doing all of this is boop. Some of the traffic that I'm using to expose internally to the or for the cluster to use its services does not get actually advertised to my Kubevirt VMs. So I have a separate DNS IP address that I use for when I'm just doing something. What I had to do was I actually had to create a DNS service on one of my servers and actually host my own local domain services for it. So I can and for some reason it doesn't work. I can't get 443 traffic through it also. So the same rancher instance that I have running inside of the cluster simultaneously with it does not actually resolve. So I'm a 443 traffic, excuse me. But I mean, I can pull my Google's traffics. I say I actually might not have my. Oh no, I'd have to because my domain services are up. Let's see, that would be this one. So really, I have these two machines resolving to my Windows domain controller right here for any of your ADUX stuff or anything like that. They're fully. These three are all on a NIC by themselves. Connected out to my network, my local home network, and all reach out externally. Inside of my cluster, I do have all of my traffic forwarding to my local DNS, and then have everything forwarded out to my forwarding out to Google. So anything I don't have. VirtCTL, if you look right here, I can also go to it. Notice how I pulled a 126, 127, 128. I basically just created a VM pool. So weirdly, how the traffic works is inside of my host, I have my physical interface of ENO2 is set as a bridge or set up with a bridge as the master. It is in part of it. And then I create my network attachment definitions, which is that VMnet pool that, let's see, VM-net. It doesn't really matter. Cube system. Notice it's that VMnet pool of IPs using the type of bridge. That's the bridge it's going to use on whatever node has that label. It's going to use whereabouts, like I said, starting that range, that IP, ending that IP, using that gateway, that local domain server. So I have my network attachment definition of Multis, which is my CNI, my container networking interface, running, connecting to that bridge. Whereabouts is just my cluster-based IPAM. And then my pod, basically, so my pod goes back right here. If we look right here, my Virt Launcher pod, which is hosting my VM, my compute on that node, is then getting one of the IPs from my network attachment definition, like we see right there. Bam, 27. And then let's go over here and let's open up this again, 134. And let me show you one of the cool things. So, and then we look right here at my IP config. Did I hit the F? Dash A. Dash. I forgot. It's Windows back and forth. We look right here. I've got my static IP that I assign it somewhere out of that VMnet range. So basically a whole lot of natting going on using the gateway for my router. It's still traversing. Got my DNS set up locally, and it's still using cluster-based DNS and everything too. So interesting. Even though it's kind of sitting separate from anything on my host itself. When you first set it up though, when you first go inside your VM and you set everything up, I have noticed your hard drives show up now already able to be attached, which are good. So your PVCs already map into your actual capability to provision your VM, load your Windows and everything. So when you first come in, you'll see something like this. You'll see PCI device. I think it's actually Ethernet device or something like that. You'll need to set all that up. So what you have to do, update driver, you'll go to browse my computer. And remember that virt.io disk we had right there? That's what we're going to go to. So we're going to go to our virt.io Windows stuff. So for the networking, you go to netkvm. Let's just do networking for now. And then you work this is Windows 2019. And I'm going to use my AMD 64 image because it's a AMD type, Intel type. With, let's see, 64-bit. You can also do any QEMU like serial stuff you have. There's a bunch of these. Serial port, VioStore, all that kinds of stuff. You can go to Kubevirt, has some stuff on their website about what drivers are what. That's how it allows you to map your internal NIC on your VM host. Basically out to your pod, out to your NAD, and out to your bridge, and then out your interface. I don't remember if I actually had an image for this set up for how the networking works, because it is confusing. If anyone has any inputs on running a domain controller or any domain VM services on like single systems like this, input is greatly appreciated. I just really wanted to share this. If anyone has any questions, ask. It's fun stuff. It's actually kind of neat. You can kind of do multi-layer stuff and run some VMs in Kubevirt, throw Kubernetes on top of that, and then run VMs on top of that. It is kind of interesting. While Kubevirt does say they only do bare metal, I have actually had it work with using Proxmox and exposing a separate NIC. You just got to do nested virtualization. It does get a little wonky, but it is possible. So yeah, thank everyone for watching, and I'm going to wrap it up. Hope you enjoyed it.